taking a stroll down memory lane a little bit, and we will be looking at some old algebra today, some old algebra that you should have had in the past, okay? If you've not had Algebra 2, just relax. I will teach this material keeping you students in mind, okay? So I will go slow, and I will explain this material well, but most of you should have had this in Algebra 1 and Algebra 2 also. Your heading today is called Linear Systems. Please copy that in your notes, Linear Systems. And the lesson today is 3.2a. We are covering half of the lesson today and then half of the lesson later on. Okay, so 3.2a, and include today's date in your notes if you would, please. Include today's date if you would. Linear Systems, lesson 3.2a, and include today's date. Okay, we're going to start off by looking at three postulates. Okay, we need to learn these from this lesson. And then we'll jump into the algebra after that. These three postulates are really important, and you are responsible for all three of these, so please learn them, memorize them, understand them, and take some really good notes on them so you know what they're saying, okay? And then we'll get into the algebra. Here's the first postulate. Postulate 12. If two distinct lines intersect, then their intersection is exactly 1 point. Please copy this in your notes. You are responsible for this on tests and quizzes. If two distinct lines intersect, then their intersection is exactly 1 point. Another way to say this is simply this: two lines can only intersect in one place. Two lines, if they're going to intersect, can only intersect in one place. Okay? Copy this theorem down. I would like you to include a little example, even though I think it's really self-explanatory. Here's a line here, and let me fix that a little bit. That's definitely not what I'm looking for. Hold on 1 second. There we go. Here's a line here. Here's a line here. And notice they're intersecting in exactly 1 point. Okay, so again, if two distinct lines intersect, then their intersection is exactly 1 point. And by the way, do you know why it says two distinct lines? It says that because you can have a line that then falls on top of another line like this, and then they're not distinct lines. They're actually the exact same line. So because of that, they have to say if two distinct lines intersect, they intersect in exactly one place. Okay, and that's why they use the word distinct lines. All right, let's continue on to postulate number 13. Postulate 13 is called the parallel postulate. The parallel postulate, and it reads as follows: if there is a line and a point not on that line, then there is exactly one line through the point parallel to the given line. If there is a line and a point not on that line, then there is exactly one line through that point parallel to the given line. All right, I'll pause just a second while you continue to write that down. You're responsible for this on tests and quizzes, okay? And I'll wait another second. Please finish copying that down. Let me give you a picture of this so you can see what it's talking about. Okay, let's take a quick glance at this, students. Here's what it's saying, and to be honest with you, it's really self-explanatory. In your notes, go ahead and draw a line like this if you would, please. And then put a point wherever you want to. I guess down here is fine. Put a point right here. And here is what this postulate is saying. Let me fix this real quick. Put a point here. There we go. It's saying if there is a line, and we do have a line right here, and a point not on that line, and we have a point right here not on the line, then there is exactly one line through that point parallel to the given line. So how many parallel lines can you draw through this point? Well, only one. There's only one line that I can draw through this point that's going to be parallel to this line. Only one. I mean, try to draw another one. If you draw one like this, it's not going to be parallel to this line right here. Okay, if you try to draw a line like this, real close like this line here is not going to be parallel to this line here. So the only thing this postulate is saying is simply this: if you have a line and a point that's not on that line, then you can only draw one line through that point that's parallel to that line. Okay, that's all that is saying. All right, postulate number 14, please copy this in your notes. It's called the perpendicular postulate. The perpendicular postulate, and it reads as follows. It's almost identical to the last postulate, only instead of using the word parallel, they use the word perpendicular, okay? So here we go. If there is a line and a point not on the line, then there's exactly one line through that point perpendicular to the given line. Please copy this in your notes. You're responsible for this for tests and quizzes. If there is a line and a point not on the line, then there's exactly one line through the point perpendicular to the given line. And here's what it's saying. Please copy this down. Draw a line and then put a point not on that line. We'll say it's right here. Now, how many lines can you draw through this point? Well, you're like, well, I can draw a bunch of them, Mr. Arrow. Yeah, that's true. But how many lines can you draw through that point that are parallel to this line here? Only one. Only one line can you draw that will be perpendicular to this line right here. And that's all that postulate is saying. If you have a point and a point, if you have a line and a point not on that line, there is only one line that can be drawn that's perpendicular to that given line. Okay? And that's all that it's saying, and that's pretty much common sense. Okay? So know these three postulates. Hopefully you took really good notes on those. And let's continue on now into the algebra. Okay? Now, a lot of algebra. So here we go. This is called a linear system. Please copy this in your notes. X minus 2y equals negative 7, 3x plus 4y equals 9. You should remember this from Algebra 1 or Algebra 2. This is called a linear system. Please copy this in your notes. The answer to this solution is negative 1, 3. The reason it's the solution is because it satisfies both equations. Let me show you very quickly. I would take notes on this if I were you. Here's your first equation, x minus 2y equals negative 7. Here's your next equation, 3x plus 4y equals 9. There we go. Okay? Now, where the x is here, I'm going to substitute negative 1. And where the y is here, I'm going to substitute 3. Because I claim the answer is negative 1, 3. So this is your x and this is your y. Well, let's see. Bring down your negative 1. Negative 2 times 3 is negative 6 equals negative 7. Negative 1, negative 6 is negative 7 equals negative 7. That worked. Now let's try the same ordered pair over here. For the x, I will substitute a negative 1. And for the y, I will substitute a 3. And let's see what we get. 3 times negative 1 is negative 3. 4 times 3 is a positive 12. And negative 3 and positive 12 is 9. 9 equals 9. So do you see how this ordered pair right here satisfied both equations? Okay? So I wanted to show that to you. So it's very important that you understand that a solution to a linear system is an ordered pair that satisfies both equations. Okay, that's real important that you know that. Now, sometimes an ordered pair will satisfy one equation but not the other, like this ordered pair. Watch this very quickly. I would not take notes on this. I would just watch. I'm going to go really fast. Where the x is, I'm going to put negative 5, and where the y is, I'm going to put a 6. Now we have negative 5 minus 12 equals negative 7. That's negative 17 equals negative 7. And then in the other ordered pair, I'm going to put 3 times negative 5, and then plus 4 times 6 equals 9. Negative 15 plus 24 equals 9. Negative 15 plus 24 is 9. So look at this. The ordered pair, negative 5, 6, satisfied this equation, but it did not satisfy that equation. So, is negative 5 is negative 5, 6 an answer to the linear system? No, not at all, because it did not satisfy both equations. It only satisfied one. Okay? Very important that you understand that. So, copy this in your notes if you would, please. This is very important. That's not the note, so please don't copy this down. This is not the note. But this ordered pair is not a solution because it did not satisfy both equations. Now, this is what you need to write down. A solution to a linear system must satisfy both equations. A solution to a linear system must satisfy both equations. It's real important that you know that. A solution to a linear system must satisfy both equations. Okay, now for the rest of the note-taking time, we will be learning 3 different ways to solve linear systems. You need to know all 3 methods, and here are the 3 methods: graphing, linear combination, and substitution. Now, you should have learned these in the past, and if you didn't, we're going to take notes on these now, but you are responsible to know how to use all 3 of these methods, okay? The graphing method, the linear combination, and the substitution. All 3 of these methods do the exact same thing, students. They solve a linear system, okay? So here we go. We're going to solve a system using the graphing method. That's the first method we're going to learn. We'll do this one together, and the next one you will do on your own. Okay, so go ahead and take some really good notes, and here we go. Copy the system in your notes if you would, please. 2x plus y equals -2, and 3x plus y equals -1. And then quickly draw a coordinate plane. Here's your y-axis, here's your x-axis, and I'll pause a couple seconds while you do that. Copy this in your notes, please, and then quickly draw a coordinate plane. Copy this linear system in your notes, and then draw your coordinate plane. All right, and then we're going to go really fast, so please take some really good notes. Okay, well, what you're going to do is you're going to graph the first line. Now, I hope you remember how to do this from Algebra 1 or Algebra 2. Usually what you do is you put 0 in. You can put 0 in for x, and then put 1 in for x. Those are 2 good numbers to use, okay? So I'm going to put a 0 in for x, and I'm going to get out a y value, okay? So where the x is, I substitute a 0. And let's see what y equals. 2 times 0 is 0. Bring the 0 over, and you're left with y equals -2. So when you put in 0 in for x, you got out -2. All right? So there we go. Not too difficult. Now, let's go ahead and put 1 in for x. Okay, now by the way, you might be saying, well, Mr. Earhart, where'd you get 0 and 1? I just chose those. I mean, they're 2 small numbers. They're really easy numbers to use. And so those are just 2 numbers I thought would be easy to use. Okay, you can use other numbers if you want to. Okay, that's totally fine. All right, let's go ahead and put in a 1 for x. All right, here we go. 2 parentheses 1 plus y equals -2. 2 times 1 is 2 plus y equals -2. Bring your 2 over and make it a -2. And -2 and -2 is -4, so y equals -4. So there we go. I'm going to plot those 2 points very quickly. 0, -2 is right here, and 1, -4 is right here. And now I'm going to go ahead and connect those 2 ordered pairs very quickly here, or at least try to. And there we go. All right, now what we're going to do next, notice that we took one equation right here. We took this equation right here. I'm going to circle it for you. This one right here, if I can get this thing to work, there we go. I took this equation right here, and I graphed it. Now I'm going to take the bottom equation, I'm going to graph it. So 3x plus y equals a -1, okay? And I'm going to put into the equation 0 and 1. So here we go. Where the x is, I'm going to substitute 0. 3 times 0 is 0. And 0 plus y is y, so y equals -1. So 0, -1 is 1 ordered pair. Now, I'm going to substitute 1 in for x. So 3 times 1 plus y equals a -1. 3 times 1 is 3, plus y equals a -1. Bring the 3 over and make it a -3, and y equals -4. So 1, -4 is my other point. Let's go ahead and plot those 2 points. 0, -1 goes right here, and 1, negative 4 goes right here. So I'm going to go ahead and connect those two lines, if at all possible. There we go. And that's not the best job, but that's going to have to do, I guess, students. Let's see if we can do it like this. All right, pretty good. And there we go. Now, here's what I want you to notice, students, and please don't miss this. Please take some really good notes and please pay attention. Notice the two lines intersect here. Where the two lines intersect, that's your answer to your linear system. Isn't that cool? Where the two lines intersect is the answer to your linear system. So this point right here is over 1 on the x-axis, and it's down negative 4. And so there's your answer. And by the way, if you want to take this ordered pair and substitute it into this top equation, you will get out a true statement. And if you want to take this ordered pair and substitute it into the bottom equation, you will get out a true statement. Okay, it does work. All right, so with that in mind, using these notes, where you take the top equation and you graph it, and then the bottom equation and you graph it, and you see where they intersect, using that method, I would like you to try this one on your own. Now follow the notes that I just gave you. Remember, your answer will be off a little when you use the graphing method, because sometimes, excuse me, sometimes when you graph your lines, they might intersect just a little bit off from where the answer is supposed to be, but you can estimate where the answer is supposed to be, okay? So don't let that discourage you. That's very normal, okay? So go ahead and try this one on your own. Go ahead and pause the video at this time, whoever your supervising teacher is, and go ahead and graph this equation, and then graph this equation, and see where they intersect, and then go ahead and unpause the video once everyone is done trying this one on their own. Okay, students, I hope everyone did well on this problem, and hopefully everyone's finished. Let's go ahead and do this quickly. Let's graph the first linear equation. You might have used 0 and 1, or you might not have. Those are the two numbers that I'm going to use. I'm going to use 0 and 1, so I'm going to substitute 0 in for x. 0 minus 2y is negative 2y. Divide both sides by negative 2, and y equals, now don't forget, a negative divided by a negative is a positive, and 7 divided by 2 is 3.5, or 3.5. Okay, so if you didn't get that right, then go ahead and correct your notes. Find your mistake, students, and then correct that in your notes. So the ordered pair 0, 3.5 is 1 point that we're going to plot. So 0 and then 3.5. Okay, now the other ordered pair, let's go ahead and substitute 1 in for x, and let's see what happens here. Put a 1 in for x. Bring the 1 over and make it a negative 1. And so now you're left with negative 2y equals negative 8. And then divide both sides by negative 2, and y equals 4. Because a negative divided by a negative is a positive. So we're left with 1, comma 4. 1, comma 4. And so we'll go over 1 and then up 4. And let's go ahead and draw our line through those 2 points. There we go. Good enough. And now let's go ahead and graph the other line very quickly here. All right. I'm going to put 0 in for x first. So 3 times 0 plus 4y equals 9. 3 times 0 is 0. 0 plus 4y is 4y. Divide both sides by 4, and you will get 9 over 4, or 2 and 1/4. Okay, so 9 over 4, 9 divided by 4 is 2 and 1/4. So what that what that means is when I put 0 in for x, I got out 2 and 1/4. So over 0 end up 2 and 1/4, which is about right there. Okay, let's go ahead and put 1 in for x quickly. 3 times 1 is 3. Bring the 3 over and make it a negative 3. 9 minus 3 is 6, and divide both sides by 4, and you will get 1.5. Now students, feel free to use calculators. Like 9 divided by 4 is 2.25 or 2 1/4. 6 divided by 4 is 1.5 or 1.5. Feel free to use calculators on that. So when we put 1 in for x, we got out 1.5. So over 1 and up 1.5, which is about right here. All right. Now let's go ahead and draw our line that will connect these 2 points right here. And that's pretty decent, not the best, but that's okay. There we go. Now we're kind of estimating. It looks like the 2 lines intersect right here. So it looks like your answer will be this. This intersection point here is over 1 to the left, so -1, and it's up 3, so -1, 3. Now let's see if that works real quick. Put a -1 here in for x, and then put a 3 in for y. -1 minus 6. Yeah, that works. That would give you -7 equals -7. And then let's go ahead and put -1, 3 here. Put a -1 here and 3 here. We get -3 plus 12, which is 9. We get 9 equals 9. So yes, -1, 3 does work. So that is the answer. And don't forget, students, we found this answer by graphing one linear equation, then graphing the other linear equation, and seeing where they intersect, okay? And this should be review from last year. It really should be, okay? So that's pretty cool. All right, moving on. Now, let's move on to the linear combination method. We'll do the same thing. I will work this one, and you will try the new one on your own, okay? So here we go. Let's go ahead and solve this linear equation using the linear combination. Now, linear combination is this. You want to be able to add your 2 equations together. You add them together. Now, when you add them together, you want your x's or your y's to cancel out. Now, don't take notes on this. Just watch and see what happens. If I add these 2 equations right now, look what I'll get. I will get 5x plus 2y equals a -3. Now, I have a couple questions for you. Did my did my x's cancel out? No, they did not. Did my y's cancel out? No, they did not. So this really didn't help any, okay? But your goal is to add these 2 equations together so that your x's or y's cancel out. So you can multiply an equation by anything as long as you do it to the entire equation. So I notice both of my y's are positive. Now, man, I wish that one of my y's was negative. If this y right here was negative, and I added these 2 equations together, these would cancel out. And that would be really nice. So is there a way to make one of my y's negative? Well, yes, there is. You can multiply the top equation by a -1, which would make this y negative. And you might say, well, Mr. Earhart, that will change all the signs up there. It will, but that's okay, as long as the y is changed. Or if you don't want to do that, you can multiply the bottom equation by a -1. Either way is fine. I'm going to use the bottom equation, and so here we go. The top equation is not being multiplied by anything, so it stays the same. The bottom equation is being multiplied by -1, so -1 times 3x is -3x. -1 times y is -y, and -1 times -1 is a +1. If you're weak with multiplying positive and negative numbers, then use your calculator. Okay, nothing wrong with that. And now we're going to add these 2 equations together. And by the way, if you're weak with adding sign numbers, then use your calculator. 2 plus a -3 is -1x. A positive y plus a negative y is nothing. They cancel out. Then bring down your equal sign, okay? And then -2 plus a +1 is -1. So look what you're left with. You're left with -1x equals -1. Isn't that easy? Look at that. And now all that we have to do to solve for x is simply divide both sides by -1. These will cancel, and a -1 divided by a -1 is a +1. Now, you might say, Mr. Earhart, how do I find y? Well, it's really simple. It's very simple. You put 1 in for x, and you can do it in any of these equations and you'll get the right answer. Now, my suggestion is to use one of your original equations because usually they're easier to use They're not messed up. Nothing's been multiplied by them. So I'm going to use this equation right here. Now remember, you can use any of these equations you want. I'm just choosing this one because I feel like it. So here we go. 3, and then where the x is, I'm going to substitute 1 because that's what x equals. And then plus y equals a negative 1. Well, 3 times 1 is 3, plus y equals a negative 1. Then bring the 3 over and make it a negative 3. So bring the 3 over and make it a negative 3. Your 3 is gone, and negative 1 and negative 3 is a negative 4. So write your answer as an ordered pair. Your x comes first, comma, and then your y. There, we did it. That's the substitute. That's the linear combination method. It's that easy, students. Okay? Now notice we didn't graph anything. Okay? The graphing method is where you graph each line and see where they intersect. The linear combination method is where you try to add two equations together and get one of the variables to cancel out. Now, I want you to try this one on your own. Follow the notes that I just gave you. You're going to use linear combination. Students, listen. I would like all of us to do this the same way, so that when you unpause the video and I work this out for you, we all have tried to eliminate the same variable. Okay, so let's eliminate the x's. Since the last problem we eliminated the y's, in this problem here I would like you to eliminate the x's. You're going to have to multiply this top equation by something so that whatever you get here with the x, I'm going to put a question mark, whatever you get here with the x will cancel with this 3x down here, okay? So at this time, go ahead and pause the video. I want everyone to try this problem on your own, and when you're done, then go ahead and restart the video, and we'll see how you guys did. Okay, students, I hope this went well for you. Here's my recommendation. If you want your x's to eliminate, and notice you have a positive 3 right here, and there's a 1 right here, I'm going to multiply the top equation by a negative 3. Okay? Now when I do that, I will then get negative 3x, and then I'll be careful here. A negative 3 times a negative 2 is a positive 6y, and then a negative 3 times a negative 7 is a positive 21. Students, please listen to me. If you missed any of this, then go ahead and fix your notes. Okay? Now let's bring the bottom equation over. Nothing changed in the bottom equation, so we'll bring that over. There we go. And now let's go ahead and add these two together. A negative 3 plus a positive 3, the x's cancel out. 6 plus a positive 4 is 10y. And then 21 plus 9 would be 30. Now divide both sides by 10, and y equals 3. Okay, there we go. Now let's come over to this equation here, and let's substitute 3 in for y. So 3x plus 4 times 3 equals 9. So next we have 3x plus 12 equals 9. Now bring your 12 over and make it a negative 12. 3x equals negative 3. And then divide both sides by 3, and x equals negative 1. So your final answer should be negative 1, comma 3. Okay? So this is using the linear combination method. Alright? Okay, let's continue on. If you're missing any of this, I hope you're erasing your notes and fixing your notes and taking care of these, okay? Alright, let's continue on. Okay, students, here we go. Let's look at our last method for the day. Our last method for the day is the substitution method. Okay, so here we go, substitution method. Now, I chose the problem here with fractions because I really feel like you need to know what to do when you have fractions in one of these. So the first thing you want to do before you try to use the substitution method is you want to try to eliminate your fractions. So notice your denominators are 3 and 3. So what you do is before you do anything else, you multiply the top equation by 3. Okay? And this will eliminate your fractions. 3 over 1 times 2 over 3 is a negative 2x. 3 over 1 times 7 over 3, your 3's would cancel, leaving you with 7y. And then 3 times 1 would give you a 3. So what I just did there is I eliminated my fractions before I did anything else. Before I tried to use the graphing method or the linear combination method or the substitution method, I first wanted to get rid of any fractions. just to make the problem a little easier, okay? Now, having done that, let me show you something real quick you need to see. You might say, well, Mr. Earhart, your denominator was a 3 and a 3, and you're right. What if this would have been a 2 right here? Okay, well, look, if that's the case, then you have a denominator of 2 and a denominator of 3. Well, you would multiply the top equation by 6 because you want to use a factor or a multiple of these two numbers right here. And 6 is a multiple of 2 and 3. Okay, so keep that in mind in case that ever happens. Okay, let's continue on. So what we did is we took our original problem, which had fractions right here, and we took a 3 and we multiplied it through so that we could get rid of our fractions. So now we have a brand new problem, which is good, and here's our brand new problem. Now, we're going to use the substitution method. Okay, now here's what you do. You look for a variable that has no number in front of it. Well, this variable here has a 3, this variable here has a 2, and this variable here has a 7. Okay? This variable here does not have a number with it. So what you do is you want to get that variable all by itself. So I'm going to take this equation right here, this bottom equation right here, and I'm going to get y all by itself. So I'm going to take this negative 3x, I'm going to bring it over and make it a positive 3x. Got it? So now the 3x is gone, and I'm left with y equals negative 5 plus 3x. This really should be reviewed from last year, okay? So I took my original equation right here, and I isolated the y. I got y by itself, okay? Now, the reason I did that, students, is I'm going to take my other equation, which is right here, and where this y is right here, I'm going to substitute this. Because look, what does y equal? Y equals negative 5 plus 3x. And so if y equals negative 5 plus 3x, then I can substitute that in. So let me get a little space here, slide this over, and let's put this back over here where it goes. There we go. And now let's go ahead and substitute where the y is. We're going to substitute negative 5 plus 3x. So I bring down my negative 2x, then my positive 7, and then parentheses, and then negative 5 plus 3x. All right, and that equals 3. And now look what I have. I have a simple linear equation that has x's all the way through it. So I can solve that pretty quickly. First thing you do is you simplify the left side. So bring down your equal sign, bring down your 3, and then we're going to take this 7 and we're going to multiply it through. Okay, so bring down your negative 2x, and then 7 times a positive 7 times a negative 5 is negative 35, and a positive 7 times positive 3 is a positive 21. Now on this left side, notice I have an x term here and an x term here, so I have a negative 2x and a positive 21x. If I combine those, I will get 19x minus 35 equals 3. Okay? A negative 2x and a positive 21x, when you combine them, give you a 19x. Now, we're ready to get x all by itself. So I simply bring the 35 over. When I bring the 35 over, it becomes a positive 35. So it's gone. And 3 plus 35 is 38. And now divide both sides by 19, and x equals 2. There we go. Now, I know what x is, but I don't know what y is. But look over here. Remember when you isolated y and got y all by itself? Y equals negative 5 plus 3x. Remember that? Well, look what you can do. Y equals negative 5 plus 3. And then where the x is, we'll substitute 2. Just like that. And now look how easy this is. Y equals negative 5 plus 6. 3 times 2 is 6. So y equals negative 5 plus 6, which is 1. So there's your ordered pair. 2, 1. 2, let's see if that satisfies both equations real quick. Put a 2 in for here, we get negative 6. Put a 1 in here, and a negative 6 plus 1 is negative 5. Let's see if it satisfies this equation over here. Put a 2 in here, I'll get a negative 4. Put a 1 in here, I'll get a positive 7. and a negative 4 and a positive 7 does equal 3. And so this ordered pair does satisfy both equations, okay? Okay, this one's on, sorry about that, excuse me. You're on your own on this one. Go ahead and copy this in your notes and pause the video and give it a shot. You're going to use the substitution method, and then when everyone's finished, go ahead and turn the video back on, and let's see how you guys did. Okay, students, hope you did well. Notice this y here has a 2, and this y here has a 4, and this x here has a 3. So the variable that we're going to get all by itself is this x right here. Okay, so let's go ahead and see if we can't split this thing up a little bit, which I think we can do, hopefully somehow. Let's see here. And that's not working, is it? Let's try this real quick. There we go. Okay, so we're going to take this equation right here, and we're going to get x by itself. So we're going to bring the negative 2y over, and we're going to make it a positive 2y. So the negative 2y is gone. So we're left with x equals negative 7 plus 2y. So there. Now we know what x equals. X equals negative 7 plus 2y. So you go to the other equation, and where x is right here, we're going to substitute negative 7 plus 2y. So 3, and then parentheses for the x. Always put parentheses when you make a substitution, students. It's very important to do. So 3, and then here's my x, and in place of my x, I'm going to put negative 7 plus 2y, and then bring down your positive 4y, and then equals 9. Now we're going to simplify the left side of the equation. So we take the 3 and we're going to multiply the 3 through. 3 times the negative 7 is negative 21. 3 times 2 is 6. And then bring down your 4y equals 9. Now we're going to combine our two y terms here, a 6y and a 4y. So negative 21 plus 10y equals 9. Okay? And then we're going to bring the 21 over and make it a positive 21. Okay? So the 21's gone, and we're left with 10y equals 30, and then divide both sides by 10, and y equals 3. Okay? Now we come up here to where x equals negative 7 plus 2y, and where the y is, I'm going to substitute a 3. And so x equals negative 7 plus 6. X equals negative 1. Okay? And so your answer is negative 1, comma 3. And trust me, this ordered pair here does satisfy both of your original equations. And this is called the substitution method. Okay, so students, you are responsible to know how to solve linear systems by using the graphing method, the linear combination method, and the substitution method. Okay, I hope this video has been a help to you. Work hard on your homework.